Today we're going to look at the basics of sets. This corresponds to section 2.1. The first thing we're going to look at is some of the terminology. So the first thing we need to know is, what is a set? So a set is a collection of objects that can be clearly defined. Element or members. An element or a member is the objects that are actually in the set. So, if I were to say the set of Anna's cats, my cats, that would be Sandy, Stabler, and Stashy. Stashy would be an element of the set, Sandy would be an element of the set, and Stabler would be an element of the set. For a set to be well defined, that means that its contents can be clearly determined, that its exact members can be specified. So with the example of the set of my cats, that is a well-defined cat. It's a well-defined set because it has 3 elements that are clearly defined. I do not own or have any other cats, and so that set is well-defined. Let's look at a couple of examples and see if they are well-defined. Are these examples well-defined? The first one is the collection of part-time and full-time students enrolled at TCC. That set is clearly defined, well-defined. So I could run through the colleague system or through WebAdvisor and determine every student who's part-time or full-time enrolled at TCC. We can do that for each semester. We can do it over a period of time. But yes, this is clearly defined. The collection of tall students in the 12th grade. So here's a problem with this one. I am 5'4". 5 foot 4 inches. So I'm actually quite short. So to me, everybody is tall. But if you are taller, like 5'9" or 5'11", then maybe, well, I think you are tall, but it's an opinion. So because we cannot clearly define what constitutes tall, and we might not even be able to clearly define 12th grade. Is it 12th grade at Birdville High School? I don't know. So because of that, this is not clearly defined. So it is not well defined. Okay? I hope that makes sense. I almost asked you if it makes sense. If it doesn't make sense, send me an email. There are really 3 different formats we use to represent sets and ways to indicate a set. The first one is to just describe the set. So there's a couple of examples that I can give you for this. First one would be if I were to say the months of the year. By saying the months of the year, we know that I'm talking about January, February, March, April, May, June, July, August, September, October, November, December. Okay, so that is a word description of a set. I could also say the natural numbers. That is a description of a set in words. Okay, those are those numbers we've discussed before, the counting numbers, 1, 2, 3, 4, 5, 6, 7, etc. Okay, so that's word description, describing the set in words. The next form is called roster form, and it's when you just list the elements of the set inside a pair of braces or brackets. So, for example, if I were to say 1, 2, 3, ... This is a roster form of showing the natural numbers. So saying the natural numbers is describing it in word descriptions. If I were to write it out like this is the roster form. Okay. If I were to write it like this and say 1, 2, ... and then say 9. Those would be the natural numbers from 1 to 9. Okay? So if you have an ellipsis at the end, that indicates that it goes on forever. If you have an ellipsis within the values or the list, that implies that it continues in the same pattern until you get to this last element. Okay? The last method to indicate a set is called set builder or set generator notation. Okay, and so what you're doing is you're defining how the set actually is generated or created. So the way we represent this is we would say, I'm going to do this in red, D is going to represent our set. Okay, the equals means is, and then the brackets show us the set of all elements X. This line means such that. Okay, and then we have a list of conditions. I'll show you what I mean. I'll give you an example. Let's make a new page. Let's suppose I have the description, the word description of the set of natural numbers less than 10. For me to write this in roster form, I would just list the natural numbers less than 10. I could write it 1, 2, ... 9 and stop there, or I could write them all the way out. 1, 2, 3, 4, 5, 6, 7, 8, 9 within the brackets. To write this as a set builder, we would say, okay, let's say D is the set, and it equals the set of all X's such that X is a natural number less than 10. Those are my conditions. I close the set. So let's take a look at a couple of very delicate and maybe very specific differences. Let's look at these symbols here. We have X is less than 5. So in words that would say X is less than 5. And below, this symbol means X is less than or equal to 5. In the first example here, these are the numbers, if I were to write it in roster form, 1, 2, 3, 4. They're the natural numbers that are less than 5. So I can't include 5 because 5 is not less than 5. If I have $5 and you have $5, I don't have less than you, and you don't have less than me. Okay? But this one down here, that I'll circle in purple, if I were to write that in roster form below, that one would include 5 because it meets the conditions that 5 is less than or equal to 5. So if it's less than 5, we count it. If it's equal to 5, we count it. Okay? So that's the difference between those two symbols. Now, if we look at this, we're going to describe each of these sets. So we're going to be given a description, we're going to write it in roster form, and then we're going to write it in set builder notation. So roster form, for this one, we have X is greater than or equal to 6. X is a natural number. So for roster form, we're going to start with 6 because it's included. And then it's the numbers greater than or equal to 6. So I have 6, 7, 8, and this goes on forever. So we're going to end with an ellipsis. For set builder notation, we're going to write this as S is equal to the set of X's such that X is a natural number that is greater than or equal to 6. So you can see that written out there. Now let's look at this set. We have X is less than or equal to 4, and X is a natural number. So in roster form, those are just the numbers, the counting numbers that are less than or equal to and including 4. So we're just going to write out 1, 2, 3, 4. Those are the elements of our set. In set builder notation, we're going to say that this set is called F is equal to the set of X's such that X is a natural number that is less than or equal to 4. Which you can see written out right there. X is a natural number less than or equal to 4. Okay, so this is a fun one. We have the set of X's where 2 is less than or equal to X, and X is less than 6. So X is between these values. It includes 2, but it does not include 6. To write this in roster form, we're going to start with 2. It's going to go from 2, 3, 4, 5, but we will not include 6. And that's because of that less than symbol right there. In set builder notation, we can say that the set S is equal to the set of x's such that x is a natural number where x is greater than or equal to 2 and less than 6. So written out, you can see that x is a natural number that is greater than or equal to 2 and less than 6. So you can say x is less than 6. Now, there is a shorthand way to do this, and I'm about to show you that in the next section, but writing all of this out can get a little tedious, so we're going to look at a different way to represent this. So please make sure you watch the next video, part 2, on the basics of sets.